We have our next presentation, and this is Muammer Semih Sonkor. He is from New York University in Abu Dhabi, a place I had the pleasure to visit and collaborate on a very interesting workshop in cybersecurity. Muammer will be presenting on towards secure construction networks, a data sharing architecture utilizing blockchain technology and decentralized storage. Thank you very much.
Hello, everyone. My name is Semih Sonkor, and thank you, Abel, for the introduction. As Abel mentioned, I work as a research assistant at New York University, Abu Dhabi, and my supervisor is Professor Borja Garcia de Soto. And today I will be presenting our paper. The title of the paper you can see on the screen. As you can see, our main focus in this paper is to improve the cybersecurity aspect of construction networks by utilizing blockchain. So from the beginning, what is cybersecurity? In a really brief way, it is how individuals and organizations reduce the risk of cyber attacks. This definition is made by the National Cybersecurity Center of the UK, and it basically says that it is how you protect yourself from cyber attacks. And what was the problem? Why did we write this paper and what we are proposing? So the first thing is about the collaboration, the collaborative nature of construction projects. So actually, it's great to have collaboration in construction projects, and we are trying to improve the collaboration by using some tools. But as the number of people increases in projects, the number of internal and external threats also increase. The second thing is about the use of common data environments. Again, it's awesome to have common data environments. It's a better way of sharing and exchanging data. But at the same time, it is centralizing the data. So it is becoming more vulnerable to cyber attacks, and also it is increasing the risk of single point of failure. Lastly, data ownership, change tracking, and access to sensitive information. So as the number of collaborators in a project increases, as the number of stakeholders increase, it's becoming harder to track the changes. It's becoming harder to track the ownership of data, and it's becoming harder to control the access, who has access to which information. So what are the objectives? What are we trying to do? So the first thing is, as many other presenters mentioned, to provide immutability. So we would like to be sure that a file has not been changed by any unauthorized authority, or it hasn't been tampered with. The second thing is providing improved access control. So again, like in construction projects, we have a lot of confidential information. So we would like to know that who has access to which information and how can we improve it. The third thing is managing large files efficiently with the use of BIM tools, such as some design authoring tools. The files are getting larger and larger in size. So we would like to manage them more efficiently and to provide improved availability. So again, we would like to have each file in the project to be available at any time. So this is our proposed data sharing architecture. We are basically proposing the use of blockchain and decentralized storage approaches together. And I will mention how it works step by step. So I think this question is not necessary in this conference since it's a blockchain conference. So I will skip the description, but the main selling points of blockchain is being tamper-proof and being decentralized. So I think most of you know already how it works. But these two terms, maybe I can explain a little bit because I will use it when I am explaining our proposal in the following slides. So what is hash? Hash is the encrypted value generated by some mathematical functions. So you are inputting a set of letters and numbers, or you are inputting data, and then you are getting the encrypted value, which is kind of the fingerprint of this input, and it is called hash. And what is a Merkle tree? It is a verification method in cryptography. And if you have a set of transactions, if you have a set of data, it gives you a single root hash value, which is the fingerprint of the set of these transactions. So what does it do? In the future, if you would like to verify the integrity of these transactions, you can basically calculate the root hash value again, and you can compare it with the original one, and you can verify the integrity of the original transactions. So I will explain step by step what is our proposal and how it works. The first step is, let's assume an architect in the project published a floor plan file. And the sizes of the files are just for the sake of example. So the initial step is dividing this original file into smaller data blocks. And then the second step is using these hashing algorithms that I mentioned. And in this case, we are using SHA-256 hashing algorithm, and hashing all these blocks, smaller data blocks, and having these hash values, fingerprints of each block. And then storing all these smaller data chunks, smaller blocks in different objects, together with the corresponding hash value, and together with the related metadata, such as the owner or the timestamp. And then in the fourth step, we are using this Merkle tree method that I've just defined. And the purpose is, okay, we have this floor plan Revit file. What is the fingerprint root hash value of this file? And then we calculate the root hash value. And then the last step about the blockchain is adding this root hash in the last block of the blockchain. So anytime in the future, this file's integrity and authenticity can be verified using this blockchain. But what about the storage of the file? I didn't mention about the storage of the file itself so far. So for this purpose, we are proposing the use of decentralized storage. So what is it? It's basically a peer-to-peer network, and each peer pulls data from each other and from whoever is nearby. So there's no central location of storing the data, and it's an efficient way of storing the data. But here you see that there's a super peer as well. What is it? It is basically a backup data server. You can consider it as a backup in the project. And the purpose is pulling each available data block as soon as they're available. So in the future, if any of the data blocks are not available in any of the nodes in the network, it will be still available in the super peer. So it kind of works as a backup system. So what are the features? It should always be online for the availability purposes, and it should only be used for storage purposes. So it should not be connected to the internet, or it should not be connected to any other external network for the security reasons. So these are some examples of decentralized storage. These are already working, and you can already use some of these projects to store your data, IPFS, SIA, Skynet, and Storage. And some of the aspects of our proposal are inspired by these projects. And these are the advantages of decentralized storage. So first of all, it provides improved transfer speed because you have data all around the network. So you are pulling these data from whoever is nearby, which increases the transfer speed. And then it provides reduced risk of a single point of failure because, again, the data is in the form of data blocks and spread it all around the network. So there's no single source of information. And it provides improved availability, both because having the data all around the network and also because the super peer that we are proposing to include in this kind of network. So this is how it looks. This is the overview of the whole system. From the beginning, there was an architect in the project, published a floor plan file, and then the file was divided into smaller blocks, and then the root hash of the file was stored in the blockchain. And meanwhile, the super peer pulled all the data and stored, and anytime in the future, any peer in the network requested these data blocks and accessed the original file. But what about access control? Because in the beginning of the presentation, I mentioned that we are also trying to provide improved access control. So for this purpose, we are proposing the use of hash tables. So what are hash tables? The hash tables are the tables that store the name of the file. That in this example, it is floor plan Revit file. And it stores the corresponding root hash value, the fingerprint of the file, and the related data block hashes for this original file, and also the hashing algorithm, and it can be augmented according to the needs of the project. But still, it doesn't provide the access control on its own. So we are proposing the use of public key cryptography mechanism for this purpose, for securing the hash tables. Because if everyone in the network has access to each hash table, it means that everyone can access every file. But in reality, everyone should have some specific access to a set of documents, not all the documents in the project. So we are proposing a secured key generator. It can be a secured software or hardware that generates these public and private keys. So the hash table is encrypted, and whoever has the private key can decrypt the table and use and pull the data. So these are the proposed features of the blockchain system in our proposal. So each block of the blockchain should be related to a single file. It is necessary because each file has a unique hash value, root hash value. So every file should be only assigned to a single block because of this reason. And then all modifications to the existing files should be shared as revisions. This is for the purpose of tracking the changes. So the file should not be revised, but the revision should be published as a new file. Of course, mentioning that it's a revision to the existing file. And every stakeholder should have a copy of the blockchain, which is one of the basic aspects of blockchain. So just to give an overview, what did we solve in this proposal? It provides verification of the integrity and authentication. So we know that the fingerprint of the file was stored in the blockchain, and we can verify the integrity and authentication of this file. It provides improved change tracking and ownership, again, thanks to the blockchain. It provides better access control, thanks to the use of these hash tables and customizing these hash tables to provide access to different parties in the project, and reduced risk of a single point of failure, again, thanks to the decentralized storage. And it provides improved availability because, again, using decentralized storage and using this super peer. And what are the remaining issues? What we didn't solve so far? There's no user authentication system in this proposal. We didn't include anything about it yet. And right now it is in a conceptual level. So there's no working prototype of the proposed system, but we are working on a prototype at the moment. And lastly, an attack against the super peer can still affect the availability, because if a file doesn't exist in any peer in the network, and if the super peer is attacked and unavailable for some reason, we can still have a problem of unavailability. So these are the references, and thank you so much for listening. And if you have any questions or if you would like to exchange ideas, you can email me in this address. Thank you.